Bismillahirrahmanirrahim. Assalamualaikum and good day, sir. My name is Michael bin Saif Nizam, and this is Muhammad Ahmad Fadlan bin Ahmad Fauzi. So today we would like to present power electronic projects titled Inverter using Unipolar PWM method. Okay, the use of semiconductor device in the field of electronic power has been gradually expanding throughout time. Basically, inverter is an electronic device that converts the direct current DC into an alternate current AC. Many applications that use inverters such as variable DC motor drive, induction heating, battery backup power supplies, and many more. The input DC voltage in PWM inverter is constant in magnitude, while the output AC voltage has control magnitude and frequency. Most PWM is generated by comparing the reference waveform with a triangular carrier waveform signal. Sinusoidal waveform signal is used for PWM in DC to AC inverter, where it is used to shape the output AC voltage to be close to a sine wave. So in this project, we will design a unipolar inverter using PWM method with the aid of circuit and result to see the analysis. So the circuit will be constructed based on the parameter that was given to us, and then output voltage and output current value of some variables will be observed.
Okay, so for methodology, a circuit of unipolar inverter had been constructed. The circuit have a value of voltage input which is 20 volt, and then the load resistance is 10 ohm and the load capacitance is 25 millihenry. So as we can see in the circuit, the in the left one is the PWM circuit. So the PWM circuit are required here in order to reduce power loss. Normally switch circuits tend to have a lower power consumption because the switching device are always off or hard on. Furthermore, PWM signals are quite easy to generate. And lastly, the PWM signal can be used to accomplish digital to analog conversion. So the right circuit is the unipolar inverter circuit that will be controlled by the PWM circuit. So for the next one is the waveform.
Okay, for the waveform, first waveform we get is from V sine gate N, V sine gate P, and V triangles. So this waveform is represents the reference and carrier signal. V sine N refer to positive, and then positive reference signal, while V sine P refer to negative reference signals. V triangular actually as a carrier signal. Okay, below that is the waveform for bridge voltage VA. The voltage VA is alternate between positive voltage DC and zero, and then the output for bridge voltage VB, the voltage VB is alternate between positive VDC and zero. Next is the output voltage of the circuit. So the output voltage circuit is equal with VO, VAB, and VA minus VP. Okay, and the last one is the output current of the circuit. Okay, next is a measured value. So measured value that we get is for V sine gate N is 0.7 volt, V sine P is 0.7 volt, V triangle 0.5 volt, VA 14.1 volt, VB 14.1 volt. Also, VAB is 16 volt, and IAB is the current from AB is 1.1 amp. Okay, next is a calculated value. So this calculated value will be compared with the FFT result that will explain by Amma after this.
Okay, so for the FFT analysis, FFT analysis run to see how much the harmonics in the circuit. So as we can see in the table, in the calculated table, the value gain and the value measured are equal. For example, for example, for Fn for Fn50, the value, the calculated value is 20 and the measured value also 20. And for Fn 1350, the measured value, the calculated value is 4.2 and the measured value also we get 4.2. So that means the value of calculated and measured tally. So that's all. For conclusion, uh, we can conclude that pure sine wave DC AC will introduce the least amount of harmonics into an electrical device, but also the most expensive method. Since the AC sine wave must come from a DC source, switching must still take place. However, switching takes place with logic so that the energy delivered to a load approaches that of a pure sine wave. Therefore, it can be derived from the waveform that a unipolar inverter with a filter circuit